Hello and welcome to Noel's Retro Lab. Today we're going to continue with the Spectravideo 328 we were working on a few weeks ago. I would be holding it in my hands right about now, except that it's over there disassembled on the operation table. So we left it with some signs of life on the Z80, but we still had no video out. So let's go back to it and see if we can get it working. Quick recap of what happened last time. We opened up this computer to find loose voltage regulators like these. Then we found out that there was no clock oscillator, so we put a new one. The fuse was blown, we put a new one, it blew up again because we had a major short in the video RAM because it had the wrong kind of chips. And the 12-volt voltage regulator turns out was putting out 15 volts because this capacitor was badly soldered. So we fixed that too. And we left it that we tested it and there were actually totally reasonable signals on the Z80. So maybe there is hope for this board after all. So one of the things we have to do now is replace the video RAM. The chips that were there were the incorrect kind and chances are they're all bad anyway, so we can't even reuse them somewhere else. Unfortunately, I don't have a lot of spares of 4116 chips. Those are most frequently used in the old Spectrum's low RAM. We can actually modify 4164 chips to work there, but I may do that later. I'll show you how to do it. It's actually pretty simple. But in the meanwhile, I realized that this bank is exactly like the low RAM bank of a Spectrum. And for that, I have this. This is a modern replacement for the low bank of the Spectrum. And because the spacing is the same, like all the sockets were together, I think this will fit right in. As a bonus, this doesn't even use the 12 volts and the -5 volts. So if we didn't have those, that would not be a big deal for that. There's some other chip that uses it. The only thing is I need to make sure that I put it this right side up. So yeah, the one is towards the bottom of the screen. So this needs to go like that. I haven't even tested this, like will it even fit? And yeah, it looks like the spacing is exactly right. This particular model has both RF out and composite video out. So we might as well choose the composite for not just better image quality, but then we avoid any potential failures in the RF modulator throwing us off. So which one is, imagine video is the bottom one and audio is the top one. Okay, here it goes. First real test. Well, we have something because again, the no video signal message went away and we have a black screen. So that's better than nothing, but I'm not too surprised that we're not getting any image. I was looking over the board after our unsuccessful test and I went, ouch. Do you notice anything weird here? Yep, this one is totally my fault. I placed this RAM chip backwards. I don't know, for some reason they're not very distinctive and I'm still not totally used to them, the one side being down because of the annoying keyboard membranes that can be unplugged. So without noticing it, I plugged in this one backwards. I even did that last video. I'm sure if you go back, it's still there. So let's fix that one. I don't think it's damaged. I'll have to look at it closely. In any case, I don't have any tests in this computer, but these are standard chips, so we'll be able to test them in other computers if we have to. And obviously we'll start by swapping that one just in case. But I'm not really sure if reversing it, putting 5 volts down the wrong way would have caused it to fail, but we'll see. So fix that. All the other ones are pointing the right way. Yep. So let's test it again. Wow, we get some image. And that sounds like the keyboard. Yeah. That sounds like keys present in the keyboard. Okay, that's interesting. So the fact that when we press keys we hear sounds, it makes me think that it's mostly working, but we're not seeing any thing in the video memory apart from some stripes. And so maybe this module is not working correctly for the system for some reason. But yeah, this is super encouraging. So you think you can definitely use the low RAM memory module for the Spectrum on the SVI 328. After all, they both have 8 16K bit chips, so 8 4116 memory modules. I was even kind of proud of thinking about using a module for something that it wasn't originally intended for. But if you look deeper, there is a crucial difference. Here we have the schematics for the video RAM of the 328. Everything seems perfectly fine. The memories are hooked up to the display processor with their address lines, their data in and out, their CAS and RAS. Yep, it all looks pretty standard. But there is one crucial difference from the Spectrum, and it actually took me talking to Ricardo, or Kip in the forums, who is the creator of that low RAM memory module. And that is that in the SVI 328, data in and data out are not tied together. There are two independent signals. But if you look at the ZX Spectrum, you see very clearly that data in and data out are tied together. Because of that, the low RAM module just assumes that data in is the same as data out, and it actually doesn't even have a connection for data in. It just connects to data out of every chip. So clearly that's not going to work on the 328. I still wanted some quick way to check if the computer was working with good video memory without having to convert a bunch of 4164 memories into 4116s. So I thought that since that low memory module didn't work, maybe one of the Spectrums in my collections would have the low RAM socketed. So I pulled it out and it checked, and nope, no luck, it didn't have it socketed. But I also have this other model, which is inside is exactly the same, it's just different case. And this one, when I opened it, ta-da, it has the low RAM socketed. It also happens to have a Nebula, which is a modern ULA replacement. But this is the important thing. And not only does it have the low RAM socketed, it actually has the 4164 chips with the mod to be able to use them as 4116s. This is great because we know this is working, so we can pop it in the other computer and test it. And then if it works, we can do the same operation on some RAM chips and put them in the other computer. Okay, the only thing is I need to make sure that I put them pointing in the right direction. So that would be pointing towards the bottom of the screen. Ready for another test? Cool. No, wait, it's not quite right. So the colors look right, but the characters are completely wrong. When the SVI 328 starts up, the screen is in mode 0, which is a text mode that has a resolution of 40 characters wide by 24 characters tall, and every character is exactly 1 byte. There's no color information because all the characters in the screen are the same color and the same background. So what's going on exactly? Let's have a look at the screen that we're getting and compare it to the screen that we're supposed to get. Okay, so they look pretty similar, but clearly the characters are wrong. So let's take the screen that we're getting and concentrate on the characters that are supposed to say basic. Here on the left, we have the character set of the SVI 328. We can take the characters for basic and write down their hexadecimal number based on that table, and then convert that to the binary number. So what we're seeing is that if we drop the last bit, so if we make the least significant bit a 0, we end up with very slightly different numbers referring to a character next to them. So really we're rounding down to an even number. If we translate that into characters again, we get exactly what we see in our boot up screen. So what's happening here is that the least significant bit of the characters is set to 0. Each bit corresponds to one of the memory ICs of the video RAM, but unfortunately they're not labeled in the schematics, so we'll just have to figure it out ourselves. Chances are the least significant bit is going to be either the one on the left or the one on the right. So I'll just look over them and... oh, what's this? This one wasn't pushed in all the way. Yeah, that would do it. Let's test it once more. Okay, that looks better. Yeah. Okay, this looks good now. This is the pinout of a 4116 chip. It contains 16K bits of memory. And this is the pinout of a 4164 chip, which contains 64K bits of memory.
They are surprisingly similar. Actually, they're almost identical, except for a couple of things. Pin 1 on the 4116 goes to minus 5 volts, and on the 4164 is just simply not connected. Then pin 8 on the 4116 is connected to minus 12 volts, and the 4164 is connected to 5 volts, so there we'll have to do some work. And finally, the only other change is that pin 9 on the 4116 goes to 5 volts, and pin 9 on the 4164 goes to address line 7, which doesn't exist on the 4116 because it's only addressing 16K, not 64K. So what do we need to do to the 4164 chip? First thing is just to cut pin 1. It doesn't need to be connected, and we definitely don't want to go into minus 5 volts. Then we need to bend up pin 8 so it doesn't go into the 12 volt rail. We definitely don't want that either. And finally, we want to connect pin 9 to pin 8. That's because pin 9 is going to be connected to the 5 volt rail, which is perfect. And we want to make sure that those 5 volts make it all the way to pin 8, which is where the 4164 needs the 5 volts. Pin 9 can stay there because it just means that A7 is always high, which is totally fine because we're only going to use 16K of the total of 64K.
And here's another reason to replace 4116 chips with 4164s. Not only are they more reliable because they don't need all those extra voltages, and it turns out I don't have any 4116s, but 4164s are cheaper and much more easily available. You can just go on eBay and buy a bunch of these for pretty cheap. So whenever I have to replace 4116s, I just make this modification to them. There we go. We're going to need 8 of them. And I'm just going to go ahead and make the modification to one of them, and then it's the same thing for all the other ones. The first thing we want to do is cut pin 1, which is the minus 5 volt rail. And we don't want minus 5 volts get into this chip. We saw what happens. We want to cut high up enough that it doesn't make contact. There we go. That's perfect. And the other thing we want to do is lift up pin 8, which is where it would get 12 volts. We also don't want that to happen. And make contact over the chip with pin 9, which is where it gets 5 volts. So we're feeding 5 volts into this pin. And now we need a small metal piece to connect this to this. What can we use for that? I saved some of my leftover pieces that I cut from resistors and capacitors when I'm soldering. And so they come in really handy. With one of those, you can probably do 3 different chips. So we really need a very small piece like this and a little bit more. So I bent it a little bit to give it the right shape. And now we just need to put it in place. So for that, I'm going to tin both this piece and the pins themselves. And that's it. Now we just need to do it for the other 7. There we have the new bank of 4164s with the mod, so they act as a 4116. And now let's try them. Hopefully everything will work like before. Perfect. Yep, that's great. We get it working. That's awesome. I was not expecting that. So now it's time to go back and clean up some of those messy cables in the back of the board. Now that we have it working, I want to fix those tracks because they look really ugly. The wire, it's even have broken in places. It's easy to short. So at least I want to replace those 2 wires over there and put some better looking ones and safer ones. Those two tracks are not great, but at least they're not going anywhere and they're not shorting anything, so I'm gonna leave those alone. So I went to test it after soldering those cables, and we don't get any video whatsoever. So I rechecked the connections to make sure that I didn't do anything wrong, and they all seem fine. I checked continuity. I even added this extra bridge as opposed to letting the wire that was there before maybe making contact where it wasn't supposed to be making contact, and nothing. Now we're getting no video out whatsoever. I rechecked the voltages again just to make sure that I hadn't accidentally shorted something and maybe the fuse blew up or something, but no, all the voltages are fine, so that doesn't seem to be the issue. So let's run some tests on the clock signal, especially the clock signal generated here at the crystal with the video chip. Okay, so first thing, let's just check the clock signal at the Z80, and that's perfect. The signal around the oscillator, the crystal oscillator right here, and we have nothing. And pin 39, there's a little tiny ripple, but we should be seeing a lot more than that. So one thing that I didn't realize earlier that I looked up just now in the circuit diagram is that this crystal oscillator doesn't generate the clock signal for the CPU. That only happens on the NTSC models. Apparently in the PAL models, the clock signal for the CPU comes from the gate array. So it's a little different there. But the video chip still needs this clock signal here for all it's working internally. So if we're not getting any signal from the crystal, then we're not going to get any video out. And as a matter of fact, video out should be 36. Should be this one. And we have nothing there either. So yeah, that definitely confirms that. Whereas the Z80, yeah, we're getting the same signals as we're getting before. And we're probably not getting CAS or RAS on the video RAM. So that should be, for example, pin 3. 1, 2, 3. Yep, no signal whatsoever. And 15. Yeah, so it looks like the video chip is completely dead and not accessing the video RAM or generating any video. So the question is it a problem with the crystal oscillator that somehow I caused some problem and I damaged it when I was resoldering those cables? Or is there a problem with the video chip that just happened to give out right at the time that we did that? I don't have another video chip to just take it out and test it. So we should maybe try to see if the crystal oscillator is working by itself.
This was the simplest circuit I could find that will test the crystal oscillator, and it's very easy to implement on a breadboard. It just has 2 inverters, 2 resistors, and the quartz crystal itself. Once we power up, we should see the crystal oscillating at its frequency.
So this is the same circuit we just saw, but actually implemented. Here we have the crystal. The inverter, this has, I think, 4 inverters or 6 inverters. So pins 1 and 2 are the input and output of one of them. And then pins, 12 and 13 are the input and output of another one. And then the couple of resistors in parallel with those inverters. And then everything connected back to the oscillator. So all we have to do is power it up. So I'm going to power it up with 5 volts from my bench power supply, like that. And then we'll need to test. I'm going to hook up the scope in here, and I'm going to test the signal, for example, at the input, like right there. Let's turn it on and see what happens. And there we go. It's oscillating perfectly. So it looks like the quartz crystal is working perfectly fine, and the problem is with the video chip. Well, that's frustrating. We were making good progress. Things were moving forward. We got video out, and then poof, something happened. It looks like the video chip blew out, and I don't have one with me. That is one of the dangers of not having a similar working machine with you. So I've ordered one, but it's going to take a few weeks to get here. So
we're going to have to pause until then, and we'll hopefully wrap this one up in part 3. I hope you enjoyed the video anyway. If so, please give it a thumbs up as usual and subscribe to the channel. Until next video, see you then.